Kit here. Just wanted to produce a quick video to share a little bit about what I've been working on. I produced my first blockchain app recently. I have an actual use case for it, and that's what I want to highlight with this video. But before we actually start playing around with my application, we need to pull some data to interact with it. And the objective here will be to work with an application which can mint smart contracts which handle payments to it, as well as disperse payments to those people who are listed as payees on the actual contract. So it's probably easier to see by way of a demonstration. So I'm going to go into my MetaMask by clicking this button right here. Notice first of all I'm on the Coven test network. My application is currently deployed to the Coven test network. Well, the smart contract is. So it's not actually on the main net at present. There's still some room for improvement, but if you want to play around with it, just be aware you need to be on the Coven test network and you also need some Coven test ETH. So I have a variety of test accounts set up. Test account 2, test account 3. Let's go ahead and pull these addresses. So first of all, we need to decide what is going to be the address actually minting this contract. And it's going to be this account here at test account. I'm going to copy that address and then I'm going to paste it here in a panel, a Sublime Text window here. This is the address of the person who will be actually making this smart contract to handle payments and the dividing of disbursements to the payees. We then need to decide on who the payees will be. And for this, we're going to switch to test account 2 here. This person currently has 0 ETH. But let's go ahead and take their address and put it in the payee section. I'm then going to put a comma there. And I'm going to go ahead and add another payee. It will be this test account 3. Let's go ahead and take that address and paste it here. So we have two payees who will currently be the beneficiaries of payments to the smart contract, which will be produced by this address right here. I'm going to go ahead now and take a look at the actual application. Okay, so here we are in part one of the app demonstration. Notice this epic green background and green button which says Connect Wallet. This is the interface for actually minting a smart contract to begin splitting some payments, sharing out payments. And we want to do it from this address here. So that is our test account address. We are going to go ahead and click this green button to connect wallet. And boom, notice that we get the address that we currently have on MetaMask. At least the one that we're currently connected to. Let's take a quick peek. So we are on test account. So you can see it ends with 293. That's where what is currently picking up on the interface, as well as the balance within the wallet itself in ETH. So the next thing we need to do is put in the payee addresses separated by commas. Fortunately, we handled that in the last step within this Sublime Text window. I'm going to go ahead and paste them in there, and notice that we dynamically get this box, this table, with the payee addresses and then a prompt to think about how many shares we want to allocate to each of these individuals. Say I want to split the payment 50-50. That means that I need to provide an equal amount of shares to each of these individuals. That could quite simply be a 1 and a 1. Or if I wanted payee 2 to get twice as much as the amount of the ETH paid into this contract, I would just switch this to a 2. So, but let's just keep it as an equal balance of 1 to 1 and then click Preview Contract. We get a contract summary, which says how many shares are going to be allocated to each address. We could go ahead and cancel the contract and it will take us back to this screen. And it's a little redundant to have to go ahead and add in everything again, but it allows you to redo things if you've made a mistake there. But once we are happy with what we see, we're going to go ahead and say Create Contract. MetaMask is going to pop up. We are working with test ETH, so this is not real Ethereum here, so don't be too concerned if you got your test Coven and you want to mess around with this. I'm going to click Confirm, and we got this little spinner that's going to be active for a bit, and we just got to be patient, and boom, we get this prompt here, and we also get this, which is very important. This is the most recent SmartSplitter address that we just created. This will be the contract that people can pay to, which will house our funds and also be able to handle disbursements to our individual payees. Let's go ahead and put this in here, contract address, and we're just going to paste that right there. So now we're going to go ahead and look at the wallet interface to basically interact with this smart contract, this smart splitter we just made, and handle disbursements to those payees that we listed earlier. Alright, so here we are in part 2 of the demonstration at the SmartSplitter Wallet interface. Same green button, but different functionality. First thing to show is that we'll be logging in with an account which isn't the admin for the account and not one of the payees. It's going to be this account one. So I'm going to set my MetaMask account to that. All of my accounts are currently connected to my application, which is why you'll see these live updates. If they weren't connected, you would have to click this green button to actually connect. But once we are connected, we do see our current wallet address as well as the balance in Ethereum. And if we take the contract address from earlier for the SmartSplitter contract we made and paste it into this get contract balance section, we get the current balance on that contract, which is 0, the address, and we get a series of buttons. So let's go deposit some ETH into this. We're going to deposit 0.0001 into there. We're going to click confirm. MetaMask will prompt us to sign, and we'll go ahead and sign that. So once this goes ahead and goes through, we should see the balance update, and we do see that happen. So now let's go take a look at one of the payee views. So I'm going to switch from account to test account 2. Notice the update in the address information, the balance on in that wallet, as well as, well, the contract stays the same, but we do get some different buttons here. We get this different withdraw payment button because this address is listed as a payee on our contract. We can also deposit ETH into the contract just like anyone else, and we're going to put in 0.0001 just to go ahead and demonstrate that function as well. So MetaMask will prompt us to sign for it, and then we have this going in. And as this goes through, you can see that we get a live update of some of the data. Now let's check out this withdraw payment button. If we go ahead and click this, because we've allocated an equal amount of shares to each payee, this payee at this wallet address should get half of this amount, 0.0001 ETH. So we're going to withdraw payment now. So let's go ahead and try this out. And we're going to click confirm. And once this goes through, we should get an update. And look at that, we get everything updating. We get a little receipt prompt right here. So we now see that the balance on the contract is 0.0001. So we can switch to the other payee address right here. And we can withdraw their portion of the payment. So here they have a very similar button to withdraw the payment. And we're going to go ahead and sign that. And this should bring our account balance down to 0. All right, so that's pretty cool. So before we switch to the admin account to disperse payment to all payees, let's go ahead and deposit some ETH into this contract because it's currently at 0. So we're going to go ahead and put in 0.2. Let's just put in a large amount like that, and we're going to say confirm. All right, so it's going to go ahead and prompt us to sign for that. So we'll eventually see this update. There you go. So now what we'll do is we'll go ahead and switch our MetaMask to the admin for this contract, which is test account. Notice that we have a different button appear here, which is the key feature for this application, which is the different rendering of button options depending on which MetaMask address you're connecting to the application. So here we have disperse payment to all payees, which should take this balance down to 0, as well as divide it evenly between the two people we have on the contract. So we're going to try this out. We're going to click disperse to all payees. Now for this one here, you do have to go ahead and put in a custom gas amount. You have to go ahead and put it at a much larger amount than what's estimated by MetaMask. And there's some room for improvement here for anyone who wants to work on this in the future. And look at that. We're going to just let this load up. And look, it brings it down to 0. We have that person's wallet balance going down. But if we check our payees, we do have those payees with a higher balance. So we can even look at it from the actual MetaMask right here. We can just see that their amounts have increased, 0.2 and now 0.4. All right, so next thing I'm going to do is just show a use case application for this app and then talk a little bit about how I made it. All right, so now I'm going to talk about an application of the payment splitter. I'm currently at the website OpenSea, which is used for collecting, buying, selling, minting NFTs. Let's say that hypothetically I'm working with a group of people and we've produced an NFT collection and we want to load those up and share out the payment for our collection amongst the whole team. So I'm at the My Collection section of OpenSea. I'm going to click this blue button that says Create a Collection. And after we would input all our data and these other forms here, if I scroll up slightly, or rather down, you'll see that here in Creator Earnings, I can enter in a certain fee for the reselling of an NFT, how much our team would receive as a result. And notice that OpenSea prompts us to add a payout wallet address. This is hypothetically where you could put a SmartSplitter contract address that you make in the contract maker. That would be if it was actually a live app on the mainnet rather than being a test app as it currently is. There's a lot of work that still needs to be made to it for it to get to a point where we could actually use it on OpenSea, but it does present us with an interesting use case right here. So now I want to talk about how I produce the Smart Splitter. And the way I did it was inheriting from an open Zeppelin contract first called Payment Splitter. Very similar name, but what I did is I added some additional functionality to that contract, which I'm going to show you. I will be linking my GitHub repos for the SmartSplitter front-end contract maker, as well as the wallet interface to this video. But in the front-end contract maker, in the README for that GitHub repo, if you click SmartSplitter Solidity contracts, you can see that in the contracts file, I have two Solidity files for the contracts which make up this application. We have the SmartSplitter, which inherits from Payment Splitter. And the big thing that I added to this were the access modifiers for only owner and only payee for certain functions. You probably noticed that as far as the buttons and how they appear for either being the admin or the payee. We also have functions for admin release all payments, well as for payees to receive their payment. Notice how the access modifier is implemented right here for only payee. So that is the Smart Splitter contract. And we also have a factory contract maker, which basically stores each of those Smart Splitter contracts in a subarray right here. And we have all sorts of functions to basically handle the retrieval of data from those subarrays. So if you are interested in Solidity, this may be something interesting for you to just take a look at. Would love feedback. Anyone who has some eyes on this. But we also have our SmartSplitter front-end wallet interface, which is very much more of a front-end app. Both front ends were made with React. The UI is using Material UI, all really basic stuff and with tons of room for improvement. The main points of improvement right now that I can think of are basically error handling for the forms, as well as error handling for when certain errors in MetaMask occur. It would be very helpful for the user to see some of that information. It would also be really cool to have additional data posted for when payments are dispersed, maybe the actual date, as well as the amount. So there's a lot of stuff you could do with this. I had a really good time working on this project. I learned a lot, and I hope it gives some of you ideas, or maybe even just motivate some of you to make some of your own apps. In general, wishing you all well. Whatever journey you're on, be happy, healthy, and thank you for watching.